Did you know that you can encounter molecular compound in your everyday life? From your house, the food that you eat, and even in the things that you use for everyday life. And that is why it is important to know what is molecular compound. A molecular compound is a compound made up of molecules, which are a group of atoms held together by chemical bonds. These molecules are neutral, meaning they have the same number of protons and electrons. In this video, we will study in detail what is molecular compound.
Molecular compounds are compounds held together by covalent bonds. Molecular compounds are compounds formed from two or more nonmetallic elements. Covalent bonds hold atoms of different elements together in molecules in a molecular compound. These are chemical bonds that occur when two atoms share balanced electrons. The atoms in the molecule are held together by the force of attraction between the shared electrons and the positive nuclei of both atoms.
Why a molecular compound has a covalent bond and not an ionic bond? A molecular compound has a covalent bond because the atoms in the compound have similar electronegativity, which means that they have a similar attraction for electrons. This means that neither atom can easily taken or given away electrons to the other atom. So they have to share electrons in order to fill their outermost electron shells and become more stable.
Characteristic of molecular compound. The intermolecular forces in molecular compounds are weak. In molecular compounds, balanced electrons are shared rather than being transferred between atoms as anionic compounds. Many molecular compounds, particularly those containing carbon and hydrogen, burn easily. Many molecular compounds do not dissolve in water because they are nonpolar. Molecular compounds lack freely moving electrons, therefore, they cannot conduct electricity. Instead, they serve as a good insulators. Molecular compounds have relatively low boiling temperature because individual molecules of covalent compounds can be separated more easily in a crystal. This property explains why many of them are liquid or gases at room temperature.
How can a molecular compound be represented? A molecular compound can be represented in several ways. Molecular formula. This is the most common way to represent a molecular compound, and it shows the number and types of atoms presented in a molecule. For example, the molecular formula of water is H2O, which means there are two hydrogen atoms and one oxygen atom.
In Lewis structure, it shows that the atoms in a molecule and the electrons in the covalent bonds between them. It uses dots to represent electrons and lines to represent bonds. For example, the Lewis structure of water is HOH, where the lines indicate the covalent bond between the hydrogen and oxygen atoms.
Ball and stick model. This is a 3D representation of a molecule where the atoms are represented by balls and the bonds are represented by sticks. It helps to visualize the 3D structure of the molecules. Space peeling model. This is a 3D representation of a molecule where the atoms are represented by spheres and the bonds are not shown. It gives an idea of the size and shape of the molecule and the relative position of the atoms. Skeletal formula. This is a simplified representation of a molecule where the atoms are represented by their chemical symbols and the bonds are represented by lines. It shows the connectivity of atoms in a molecule.
Examples of molecular compounds. A few examples of molecular compounds include water, carbon dioxide, methane, carbon monoxide, ammonia, oxygen, nitrogen, chlorine, hydrogen chloride, sulfur dioxide, hydrogen sulfide, nitric oxide, carbon tetrachloride, ethylene, acetic acid, formaldehyde, ethanol, sucrose. Properties of covalent compounds. Most covalent compounds have relatively low melting points and boiling points. Covalent compounds usually have lower enthalpies of fusion and vaporization than ionic compounds. Covalent compounds tend to be soft and relatively flexible. When dissolved in water, covalent compounds don't conduct electricity. Covalent compounds tend to be more flammable than ionic compounds. Many covalent compounds don't dissolve well in water. Industrial application of molecular compound. Covalent compounds find extensive uses across various industries due to their unique properties and versatility. Let's explore some critical application.
Polymer production. Covalent compounds play a crucial role in polymer production. Here, monomers undergo polymerization to form long chains or network. This results in diverse and versatile materials with wide-ranging industrial applications. Polyethylene, polypropylene, and polyvinyl chloride are examples of polymers. They are derived from covalent compounds that manufacture plastics, fibers, and packaging materials.
Pharmaceuticals and biotechnology. Covalent compounds serve as essential components in drug development and biotechnological research. Pharmaceutical drugs often contain covalent bonds that determine their chemical stability, solubility, and interaction with biological targets. Biotechnological processes such as enzyme immobilization and DNA modification, they rely on covalent chemistry to create functional biomaterials and therapeutics.
Agrochemical and pesticides. Covalent compounds form the basis of many agrochemicals and pesticides used in agriculture. They enhance crop yield and protect against pests and diseases. Herbicides, insecticides, and fungicides contain covalent bonds that confer specific chemical properties for targeting and controlling pests and pathogens.
Adhesives and sealants. Covalent compounds are essential ingredients in the formulation of adhesives and sealants used in construction, automotive, and aerospace industries. These compounds provide strong bonding capabilities, weather resistance, and durability, ensuring reliable adhesion and sealing in various applications.
Electronic and semiconductor. Covalent compounds are integral to producing electronic and semiconductor materials, including silicon-based semiconductors and organic electronic devices. Semiconductor materials like silicon carbide and gallium nitride exhibit unique electronic properties. These properties stem from their covalent bonding structure, enabling the development of advanced electronic components and devices. Textile industry. Covalent compounds are used in the textile industry for dyeing, printing, and finishing. Reactive dyes from covalent bonds with textile fibers and provide durable and color-fast finishes in textile products.
Cosmetics and personal care products. Covalent compounds contribute to the formulation of cosmetics and personal care products, providing stability and functionality. Emulsifiers, surfactants, and thickeners utilize covalent bonding to create stable formulation with desired properties.
Construction materials. Covalent compounds produce construction materials including concrete, ceramics, and glass. Silicate-based materials like silica gel and silicones rely on covalent bonding. This bonding ensures structural integrity and durability in various construction applications, including sealants, adhesive, and building materials. And that is all you need to know about the properties of molecular covalent compounds in their relation to their structure. I hope you enjoy, understand, and learn in this video.